Hello students, welcome back to Turito's live classes. How have you been? I hope you are having great time. Students, we have started this chapter known as what is matter around is pure, correct? And now we are in the next session of this chapter where we are going to discuss about what some types of solution, right? Though we have covered many types of solutions which are based on the solvents which we are using or the type of particles which we are having in the solution, or I can say more specifically the particle of the solutes, correct? So based on that we have seen saturated solution, we have talked about unsaturated solution, then a supersaturated solution, correct? So after that we talk about or in the last class we have started with true solution. I hope you all are able to recall what true solutions are. Okay, that was the topic in a discussion in our last class. So we have seen a proper definition about true solution. So what do you mean by true solution? True solution is nothing but it's a homogeneous mixture. I have given you one example such as what if we are adding salt in water and we are going to stir that solution. What do we observe? We observe that after some time I am not able to pick out the salt particles. I am not able to see the salt particles because these particles are completely dissolved in water to give you uniform solution, or the components are getting dissolved with each other uniformly. That type of solution is nothing but what? Homogeneous mixture, correct? Or I can consider this type of solution as homogeneous. Okay, so true solutions are mostly homogeneous type of mixtures, correct? Then the components of solution do not chemically react with one another. Just now we have prepared salt solution and we know that these salts are, the particles of salt are just dissolved with water molecules, correct? We don't see any formation of new substance, or there are no any chemical bonds which are present between these two matter, correct? That means no chemical reaction had happened here. Okay, it's just a dissolution between two different types of particles. Again, it's very important how do we recognize, or what is the next property of true solution, which is nothing but that the size of the particles are smaller than 1 nanometer. The size of those particles is what? Smaller than 1 nanometer. 1 nanometer is equal to 10 raised to minus 9 meter. It is very small. Okay, so 10 raised to minus 9 meter, correct? So they cannot be seen through naked eyes or even under microscope. Students, definitely imagine sugar solution, imagine salt solution. Are we able to see sugar crystals or salt particles? Because they are very minute, because they are very small. How small? They are less than 1 nanometer. 1 nanometer is equal to 10 raised to minus 9 meter. They are very small. We cannot see them through our naked eyes or not even under microscope. So these are some properties which we have learned about the true solution. Let's move ahead. Next property, which is again very important property, which is nothing but what? Scattering of light. So do particles of true solution show this property? Let's see. Because of small size, particles do not scatter beam of light passing through solution. They are very minute, they are very tiny, that they cannot show the scattering. Okay, if we are going to put torch on it, we have this picture here, right? So this is, just a minute. So we have two images basically. To compare A with B, I have kept these images. What this B is, forget about the like the word colloidal solution, or this is a type of solution which we are going to cover soon, but focus on true solution, okay? Or this is the property which is shown by these two properties but in a different way. How? A has what? True solution, okay? This is what is a beam light. These are some particles which are less than 10 raised to minus meter, student. Okay, so the particle size is very small. When beam of light is passed over that solution, there is like we see the beam of light is not visible, or I can say that the scattering, the particle has no tendency to scatter the light which is there on the solution. Okay, so because of their small size, they do not scatter the beam of light. The particles of solute in solution pass through the filter paper, therefore the solute particles are smaller than pores of that filter paper. It's very simple. What are they saying? They are talking about the next property of true solution, which is nothing but what? Filtration. I mean the separation technique, which with the help of which we can separate the true solution, which we cannot even separate the particles of true solution with what? Filtration. Because I told you that filter paper with the we are going to use filter paper and we are going to do filtration basically. When we do that, what do we observe? That we don't collect any substances, any molecules on the filter paper. Okay, we are just going to see, suppose this is a funnel, correct, in which you are going to add a filter paper, and to this you are going to add solution, that is true solution, okay, which has particle size smaller than 10 raised to minus 9 meter. If you are going to pour such solution, what do you observe? That the size of particle is such a small that we say no collection of any particles, because the pore size which filter has is quite, sorry, the size which solute has is very smaller, that we cannot collect those solute particles or particles that are present in the solution. That's why solute cannot be separated by what? Filtration. That's the next property of true solution. Okay, next is when solution is allowed to stand undisturbed, the particles of the solution settle. This shows the solution is stable. Okay, a solution is always transparent in nature, it may be colorless. So, I hope you all are able to remember the example which I have given, that copper sulfate. If you are going to add pinch of copper sulfate crystals to the water, you are going to get the blue colored solution which is transparent in nature, or it is transparent solution. So, try to understand that true solution is always transparent in nature, correct? Let's move ahead. Then we talked about the very important topic for this session, which was concentration of solution. Now, what do you mean by concentration of solution? The amount of solute in a given solution is called the concentration of the solution. Here we are going to measure, we are going to see like how much solute is being added to the solution. Okay, that is going to decide the concentration of the complete solution. A proportion of solute and solvent is not even, we do not fix the portions of solute and solvent to get mixed up. So, as proportion of solute and solvent is not even in a solution, therefore depending upon the proportion of solute, a solution can be divided into dilute and what? Concentrated solution. So, I hope you all are able to remember the diagram which I showed you here. Let's quickly jump on the diagram. Students, this is what is a dilute solution, this is a concentrated one. The type of solution where we are having less solute concentration. Okay, so here we are adding solute in less quantity. So, concentration of solute is less in diluted type of solution, whereas in concentrated solution with high solute concentration. So, here this type of solution is with high solute concentration, correct? The amount of the solute which we are adding is higher in concentrated solution. Next, in dilute solution, on increasing the amount of water, solution can be further diluted. You can dilute this type of solution by adding more water to the solution. Okay, you can dilute it further. Here in terms of concentrate solution, on increasing the amount of solute, it can be further concentrated. Here you have added water to make it dilute. In concentrated solution, what you can do, you can add more salt to make it concentrated. Okay, the amount of solute can get added more to make it more concentrated. Got it? Let's move ahead. Here we are having combination of a solution where solid in, we are saying solid in liquid, solute is solid and liquid is solvent. Okay, so now if we want to we are going to measure the concentration, we are having different terms such as what? Mass by mass percentage. we are going to measure, we are going to calculate the concentration in terms of percentage, mass by mass. Okay, so it's a small w, capital W, it's a percentage. All right. So how do we define this? The mass of solute in grams dissolved in 100 gram of solution. Okay, that is going to give you mass by mass percentage. We are provided with mass of solute. Okay, it's now we need to divide it with the mass of the complete solution, and all you have to do is to just multiply it with 100. That's how we are going to get W by W percentage, or mass by mass percentage of that solute. Alright, here I have given you one example. Suppose if you want to prepare 10% of solution of common salt, how are you going to do that? You are going to take what? 10 gram of salt in 90 gram of what? Water. Okay, which is going to give you 10 gram of solution of common salt. Okay, that is mass by mass percentage, student. Next we have mass by volume percentage, mass by volume. So here we need to understand the mass of solute in grams dissolved in 100 ml of what? Solution. 100 ml of solution. How much, like how salt which is there, like the unit is what? Gram. So how much solute in grams is getting dissolved in 100 ml of what? Solution. So how do we write it? This is a chemical this is the formula which we are going to use to solve some numericals. Okay, so this is very important. This is what? Mass by volume percentage. So definitely you need mass of solute which is divided by volume of solution. This volume is in what? Milliliter. Mass is in what? Gram. Correct? Definitely you are going to multiply it with 100. Alright. So again it is same. If I want to prepare 10% by volume solution of salt, how are we going to do that? We are going to add 10 gram of salt in 90 ml. It is in volume, right? So 90 ml of water. That's it. Next we have, if a solution is prepared by dissolving a liquid solute in liquid solvent. Here we are moving towards the next type of combination of solute and solvent, where we are going to prepare a solution by dissolving a liquid solute in liquid solvent. The concentration of the solution may be expressed either in volume or percentage. Okay, so here we are going to volume by volume. So here we are having liquid which is getting dissolved in what? Solvent such as liquid in liquid. So we can calculate, measure its concentration in volume percentage. Okay, the volume of the solute in ml dissolved in 100 ml of the solution. It's what? Liquid in liquid. It's very simple, students. Liquid solute is getting dissolved in liquid solvent. Okay, so the volume of the solute which is there in ml. Okay, so how many ml solute I am dissolving in 100 ml of solvent. Okay, 100 ml of what? Solvent. So volume of the solute in ml dissolved in 100 ml of the solution. Okay. For example, we are having 20% by volume solution. So student always focus on what kind of concentration they have asked or they have prepared. It is by volume solution of, here is a chemical or liquid alcohol in water. It's volume by volume. Alcohol is liquid, is getting dissolved in what? Water, which is liquid. So what kind of solution it is? Liquid in liquid. Correct. So it's 20% by volume. Alright. 20 ml of alcohol. See, it's 20% by volume solution of alcohol in water. 20 ml of alcohol dissolved in 100 ml of water. So how do we prepare it? It's very simple. Take 20 ml of alcohol and dissolve it in 80 ml of water. Volume by volume. Okay, so both solute and solvent are in liquid state. Alright. So here is the formula for that. Volume by volume percentage. What is the combination of solution is what? Liquid in liquid. Okay, this is what is the combination here, and that's why So volume by volume. We measure liquids in volume. That's why it's volume by volume percentage, which is going to give you concentration. Correct. So the volume of solute in ml dissolve in 100 ml of solution. So it's again remains the same, but we are going to change the unit here. Alright, it's not mass, it's volume first of all, and which is again in ml. Okay. So volume of solute in volume of divided by volume of solution into 100. Got it? Is there any doubt? Just to make note of this formula, students. Done? If you want to quickly just go through all the formulas which are very important, mass by mass. Okay, this is the one. Mass of solute divided by mass of solution into 100 is going to give you mass by mass percentage. Okay. Next to this, mass of solute, your volume of solution into 100. It's mass by volume percentage. Mass by volume. Okay. Then what do we have? Next to this, the third, liquid in liquid, volume of solute divided by volume of solution into 100. Alright. So let's move ahead and try to solve some questions which is based on this formulas. Okay. So your question number 1 is what? A solution contains, so we have taken a solution which contains 40 gram of common salt in 320 gram of water. Okay. So I am just writing it here for your better understanding. Just a minute. So we have prepared a solution. We are going to understand the question first. Solution, we know that how it gets formed when you add little amount of solute in what? Solvent. It's going to give you solution. So a solution contains 40 gram of common salt. So solute is salt, which is 40 gram. Okay. Of water. Water is your solvent. Calculate the concentration in terms of mass by mass percentage of the solution. 40 gram of solute is getting dissolved in water. I am just going to write the name of the solvent, which is what? Water here. Salt, which is your solute, which is 40 gram. Alright. So, students, a solution contains 40 gram of common salt in 320 gram of water. So, what is the mass of the solvent here? 320 gram of water. So, what we have done, 40 gram of solute is getting dissolved in 320 gram of solvent. So, we are provided with solute, that is salt, and solvent, which is water. So, what they have asked, calculate the concentration in terms of mass by mass percentage. It's very simple. We know the formula and quickly we are going to solve this, right? So, firstly, mass of common salt, which is given 40 gram, alright. Second, mass of the solvent, which is 320 gram. Okay. Students, to find out the mass of the solution, what we will have to do? How are we going to find out the mass of the solution? Solute plus solvent, right? Solute plus solvent, 320 plus 40, you are going to get it as what? 360 gram. Correct? So, that's why the mass of the solution is what? 360 gram. We are having solute 40 gram, we are having solvent 320 gram, and we are finding out the mass of the solution 320 plus 40 going to give you 360 gram. That is the mass of the solution. Why are we calculating this? Because I hope you remember the formula, which is nothing but mass of the solute divided by mass of the solution. I am just going to write the formula here. Mass of solute, mass of the solute divided by mass of the solution, okay, into what? 100. So, this is going to give you concentration. How? Mass by mass percentage is going to get calculated. How? mass of the solute. So what is the mass of the solute? It's 40 gram, right? And mass of the solution. So solution, this is where is we have calculated, it's 360 gram. And we know it's percentage, that's why I need to multiply with 100. Let's calculate this. If you are going to calculate it, you are going to get answer like this. Quickly divide it 10. Okay, it's 11.1 percentage. Okay, yes, don't forget to write it because this percentage has half mark. Okay, so write your complete answer. We are calculating this concentration as percentage. So what is the concentration in terms of mass by mass? It's 11.1 percentage. Okay, so what we have done, students, we have taken solute and solvent. Solute 40 gram, solvent 320 gram. They are asking us to calculate W by W percentage, mass by mass percentage. That's the concentration they are asking for. So what we have done, we have just added, to find out the mass of solution, we have added mass of solute and solvent, which is going to give you 320 gram of that is the mass of the solution. Now just put the values and do the calculation and get the answer. That's it. Easy, right? Okay, quickly note down, students, I have given you the solution. Got it? Let's move ahead towards the next problem, students. So focus on the problem. A solution contains 5 ml of alcohol. Okay, alcohol in 70 ml of water. So I know it's a solution of alcohol in water. Just a minute, let me use the proper marker. So solution and solute. Quickly divide the part, solvent and what? Solute. So 5 ml of alcohol. Okay, alcohol is the solute. So what is the quantity of it? 5 ml in 70 ml of what? Water. Water is solvent, that's it. So quickly calculate the volume by volume percentage. So here we just going to calculate volume by volume. Earlier we have calculated mass by mass. Students, it's alcohol, liquid. It's 70 ml of water, liquid. So combination is what? Solute is liquid, solvent is liquid, and that's why they are asking the concentration volume by volume percentage. So 5 ml, 70 ml, 75 ml what? Volume of the solution, correct? Firstly, volume of alcohol is 5 ml, then we are having volume of water which is 70 ml. Volume of the solution, solvent plus solute plus solvent is going to give you 75 ml. And rest job, rest part is very easy job, where we are going to calculate volume by volume percentage of solution, volume of solute divided by volume of solution. So how much is this? 5 is the volume of alcohol, which is your solute. Volume of solution is what? 75 into 100, right? So here is the simple calculation, students. We are going to divide it by 5. So we are having something like this, correct? Then 3, 4, correct? Then it is going to 20 by 3. Now what you are going to do, you are going to divide 3 by 20, right? So 6, correct? If I am going to, 20, so 6.6, right? Left with 2. So of course the answer is what? 6.66 percentage. Do not forget to write percentage, okay? 6.66. So that is the concentration of this liquid in liquid type of solution by volume by volume percentage. Alright, quickly make a note of this, students. It's very simple. Earlier we have calculated concentration in terms of what? Mass by mass percentage. In this example we have just calculated concentration in volume by volume percentage. Okay. So they have given the volume of alcohol, volume of water, volume of solution, and just do the simple calculation and you are done with your answers. Alright. Quickly make a note of this, students. Done? You are supposed to be very fast while writing, while noting down things from the board, okay? I hope you have done with this. Have you all? Let's move ahead. Now this next question says 2.5 gram of solute, okay, are dissolved in 25 gram of water. Solute in dissolved 25 gram of water to form a saturated solution at 298 Kelvin. Okay, saturated solution, that means like no extra amount of salt, the solute can get added in the solvent. That's what saturated solution is, if I am not wrong. Are you all able to recall the concept? Saturated solution, we cannot add further solute in solvent, right? It's happening 298 Kelvin. Find out the solubility of the solute at this temperature. So what is the solubility of the solute? Like how much, like what is the maximum capacity of that solute to get dissolved in the solvent at this temperature? That is what they are asking for. Okay, so here is the little trick here. It's quite like different from the last two questions. So we are provided with mass of solute, 2.5 gram of solute. So that's why we can write whatever it's given. Always try to write down the data which is been provided in the question. So write solution and then pen down each and everything which is there in the question. So first thing is that mass of solute. So how much is this? It's 2.5 gram. Next to that we are having mass of the solvent. So 2.5 gram of solute are dissolved in 25 gram of water. So that becomes your solvent. So quickly note down mass of the solvent. Now third, they are asking solubility of this solute. So here is the formula, mass of this solute divided by mass of the solvent into 100. So, okay, I will write it here again. To calculate the or to find out the solubility of solute, what we will have to do, we are going to write the mass of the solute which is there, okay, divide the mass of what? Solvent. Okay, mass of the solute divided by mass of the solvent. Like how much of the solute is getting dissolved in that solvent is going to give you solubility. Simple, right? And it's happening in what percentage? Like they are asking solubility in percentage. Obviously need to multiply with 100. So mass of the solute is what? 2.5 divided by 25 into what? 100. So what are you going to do? Simple. Is going to give you what? Sorry. It's what? 2.5 into 25 into 100, right? Yeah, that's it. It was so simple. It's going to give you 10 gram. Okay? Is that followed? So quickly you can make a note of this, students. So to find out the solubility of solute, just write the mass of the solute divided by whatever the mass of the solvent is given into 100 and do the simple calculation. That's it. Is it clear? Okay, that was all about it, students. So concentration terms and questions based on the those concentration terms we have covered, right? So it's time to move ahead and try to understand the next type of solution, that is nothing but what? Suspension. So here in a suspension we are going to see something quite different than the true solution. Okay, so let's see what is that. So suspension is a heterogeneous system in which the solute particles do not dissolve but remain suspended throughout the bulk. And that's why the word is suspension. They are the particles which are there in the solvent, they are not going to dissolve like the way solute particles got dissolved in the true solutions. Okay, so here in suspension these particles are going to be there, remain there, they are going to be suspended, and that's why we say whatever we get out of that is what? Suspension. It's a heterogeneous mixture, of course. It is not going to look like the salt solution or sugar solution. So here I have given examples such as what? Imagine we are having chalk powder, okay, and if you are dissolving chalk powder in the water, what do you observe after some time? Like do the water, chalk powder particles are going to get dissolved in water? No, right? They are going to be there. They are going to remain undissolved. And that's why we say whatever we have obtained out of this, it is a suspension. Okay, chalk powder in water is an example of what? Suspension. It's a heterogeneous mixture. See, these are water molecules. Like some water molecules are there, some chalk particles are there. We can see them with our naked eyes, right? There are boundaries which we can see. Okay, it consists of two phases basically, solid and liquid, and we can see it very clearly. That solution, that type of mixture is what? Heterogeneous mixture. So always remember, suspensions are heterogeneous in nature, okay, whereas true solutions are they are homogeneous type of mixtures, correct? The particles of suspension are visible to naked eyes. Yes, and importantly we have to understand what is the size. It's greater than 10 raised to minus 6 meter. That is the size which we observe in particles of suspension. In a true solution, what was the size of this particle, students? Can anyone tell me? It was smaller than 1 nanometer. Here it's greater than 10 raised to minus 6 meter. Correct? So that is what suspension is, and one of the example is what? Chalk water. Then we are having muddy water, then sand particles in water. Can you imagine this types of solution? Okay, so I can see mud particles in the solution. Okay, they are visible to our eyes. Next to that, sand particles are visible when we try to make a mixture or a kind of a solution, when we dissolve sand particles or mud particles. They do not get dissolved, they do not going to give you true solution because it's a type of a suspension. Okay, because they are having size which is of 10 raised to minus 6 meter. Okay, so make a note of these 3 points, students, quickly. We are talking about the next type of solution, which is suspension. The particles of this solution is what? Greater than 10 raised to minus 6 meter, which is quite visible to our eyes, unlike true solution, because the size of the particles is what? Like 1 nanometer or smaller than 10 raised to minus 9 meter. Correct? Okay, let's move ahead. So let's try to understand what are the different properties suspension has. Suspension is a heterogeneous mixture. Of course, that's what we have studied just now. Then we are having a particle size. So here true solution, particle size is less than 10 raised to minus 7 centimeter. Okay, like less than 1 nanometer. And as of now, just avoid colloidal solution. And here let's talk about the suspension. Particle size is greater than 10 raised to minus 5 centimeter. Okay, so they are very bigger in size, so we can observe the particles which are present in the suspension, and it becomes very hard to observe the particles which are there in true solution. Okay, so that is the difference between the true solution and suspensions. Okay, and like these are two extreme type of solutions. In between we are having colloidal solution, and we are going to talk about this solution later on. Let's move ahead. The particles of suspension scatter a beam of light passing through it and make it path visible. So when the particles settle, yeah, that's the next property, students. We need to understand it first. So we are having something called as what? Tyndall effect. It's a Tyndall effect. Okay, so what it means? Scattering of light by colloidal particles is known as Tyndall effect. Okay, so here focus on suspension, students. So I'm sure you must have seen, like when sunlight is passing through the canopy of the dense forest, have you all observed that the air molecules which are there in that canopy is quite visible to our eyes whenever we see the beam of sunlight. Okay, these particles, these air particles are reflecting light, or that beam is getting reflected, and eventually we are able to see the particles whenever we see this canopy. This is nothing but what? Tyndall effect, where we observe scattering of the light and the particles are getting visible to our eyes. Same thing is being observed when we talk about what? Suspension. The particles of suspension scatter a beam of light passing through it and it makes its path visible. That means it shows Tyndall effect like this. Okay, so here is the flashlight. This is a solution. We have seen solution do not show, it does not show what? Tyndall effect, or it does not scatter the beam of light. Okay, as of now ignore colloid, but here the particle size is quite bigger. Okay, and that's why the particle is going to what would reflect the light, and the particle is what? Quite visible. All right, so this is the important property of suspension. When the particles settle down, the suspension breaks and it does not scatter light anymore. Okay, students, it happens when the suspension has particles which are suspended. Suppose this is what is the suspension and the particles are suspended. Okay, after some time when we observe, in case of chalk powder is going to get what? Settle down after some time. That time, if you are going to put a torch and see, that there won't be any scattering of light, because whatever the particles we had here earlier, they are now settled down, and that's why no scattering of light will happen in suspended particles, because they are settled down particles. Suspended particles can show the scattering of light, but here after they are going to settle, after some time they are going to settle down and they cannot show the scattering of light. Okay. Next to that we have what? The solute particles settle down when a suspension is left undisturbed, that is the suspension is unstable. Okay, so here we are having some example, students, such as what? When carbon dioxide is passed through lime water taken in a test tube turns milky. Okay, so what do? We take carbon dioxide and we are having lime water, that is calcium hydroxide. Okay, when this calcium hydroxide is experiencing carbon dioxide, or they are reacting together, what happens in a test tube? Suppose this is a test tube. Okay, lime water is being taken and now we are passing carbon dioxide to it. This turns milky white. Can you see? This is milky white. Okay, why? The solution turned milky due to the formation of suspension of calcium carbonate. Chemical reaction had happened. Calcium hydroxide reacting with carbon dioxide, and whatever we say here, it is what? Calcium, like the formation is of calcium carbonate. Earlier we have taken here calcium hydroxide, CaOH twice, lime water, and reacting with what? Carbon dioxide. It is giving you formation of calcium carbonate and turning what? The solution is what? Milky white. When it allowed to stand undisturbed for some time, the particles settle at the bottom of the tube as precipitate. Definitely, students, the suspended particles are going to get what? Settled down at the bottom of the test tube, and that state is known as what? Precipitation, or the precipitate particles being observed. We have taken lime water, calcium hydroxide. Okay, it's a base. When we pass carbon dioxide on it, we say the test tube or the chemical which is there in the test tube is now milky white. Why? Because new substance had formed, calcium carbonate. Okay, that is the confirmatory test of calcium carbonate when CO2 is getting passed over calcium hydroxide. Also, it's a confirmation test of what? Carbon dioxide. Okay. So, after some time we observe the particles, suspended particles are going to get what? Settled down, and this is what is the property of suspension, and that's how we say suspension is what? Unstable. The suspended particles are going to get settled down at the bottom. Here is the real life example, student. This is what is muddy water. After some time, what do you observe? The suspended particles now they got settled down. Okay, this shows that instability of the suspension. Okay. Next is they can be separated from the mixture by the process of filtration. Definitely here the size of the particle is quite considerable. They are large. Filtration will work here. Okay, so that's why we have taken example of chalk in water. If you are, these are the chalk particles, students, this is water, this is filter paper, and once you have started the filtration, all you get here is what? Water molecules, because the chalk is getting collected here, chalk powder is getting collected here, and that's how we can separate what? Suspension with the help of filtration. Got it? See, this water is known as filtrate. Whatever we are filtering out and collecting in a separate container is nothing but filtrate. And whatever is the remaining on the filter paper is what? Residue. What do we call it as? Residue. Got it? So, here are some examples, students. Pens are suspensions of colored substances in water or some other liquid. So, pens are real life, like one of the real life examples where we see suspension. See, suppose we are using pens and the cans are being kept for a while. You just try it at your home. After some days, you are going to see that some like liquid is there on the top of the can and some particles are suspended. Sorry, the particles are settled down at the bottom. It's a suspension, right? Milk of magnesia is suspension of magnesium hydroxide in water. Okay, it is also one of the example. Okay, so milk of magnesia is a base. Okay, when we feel indigestion because of excess hydrochloric acid in our stomach, to neutralize that we add milk of have milk of magnesia, which is a base, and also it is a example of suspension. Then next to that we are having lime water used for a white wash is a suspension of calcium hydroxide in water. Just now we have talked about it. Calcium hydroxide in water can be considered as a suspension. Okay. Next to that we are having bleaching powder in water is also a suspension, since bleaching powder is insoluble in water. Okay, so these are some examples. This is bleaching powder, this is was lime water. So students, these are some example. When we are going to make solution of this, the type of those will be of suspension, because the particles are going to get suspended and after some time they are going to get settled down at the bottom of the container, because they have size, like the particle size is greater than 10 raised to minus 5 meter, right? So that is the property, or that is all about the suspension. So we have covered like what are true solutions. We have solved some numericals based on true solutions, and in this session we have talked about suspension. Students, in our next class we are going to talk about colloids. Okay, so be prepared for that, and please revise whatever we are finishing lecture wise. Okay, so that every concept won't get pile up. Okay, just make your task easy by studying it daily. Alright, that was all about today's session, students. We'll be meeting in next session. Till then, bye bye, take care.